So in this lesson, we're going to introduce the transformations of sine and cosine, and this lesson is going to continue for 4 lessons. So in last lesson, we learned about 3 important qualities of sine and cosine, and that's midline, amplitude, and period. So to start out, if you want to pause the video and read over these, you can. I'm going to jump right into the problem so the video is not super long. So here, we're going to identify the midline, the amplitude, and the period of each of these graphs, as well as the maximum and minimum value. So the maximum and minimum are just the highest and lowest y value. So in my first graph, I see it goes up to 3 as the highest y value and -3 as the lowest y value. The midline is going to be always directly in between that max and min. So this one is a pretty obvious 0. If you ever need to find the midline and you just can't tell where it is, it's just an average of the max and the min divided by 2, right? Because there's 2 values, so that's 0. So sometimes, like the next graph, it's not super easy to see. You might want to use that. The amplitude is always from that midline up to the maximum. At any point, you see it's always the same, so the amplitude is 3 in this case. And then the period, probably the trickiest part to figure out. I usually just start on the y-axis, and then I repeat the graph until I get to a point that I'm going to see if I kept going, and I'll do it in a different color, we would just get the same pattern over again. So the period of this graph, starting from 0 and going to pi, so the period is pi. Now, when you do this, 2 thoughts. You can start anywhere. The y-axis is just kind of like a standard spot to start. And secondly, you'll notice that when we did the basic graphs of sine and cosine, the amplitude was always 1 and the period was always 2 pi. So this is a transformed graph, which is what we're working on today. Moving to the second graph, max value is 9. Min value is -1. So maybe I can figure out exactly where that midline is. It looks like it's about here. And also if I average those values, that's 8 divided by 2 is 4, which looks like it's in line with what I have. And I should have written this in the first one, but often with midline, we'll write the equation of the midline. So that is y equals 4. This one I could have written y equals 0. It's always a horizontal line. Amplitude from that midline to the maximum is 2, 4, 5. And the period of this graph, so we'll trace it out. Starting value, this looks like it has that sine pattern of up, down, and up. That's where it's going to start repeating again if I kept going. So that's 180. So this isn't typical, but this one is in degrees. Usually we use radians. So I'd like you to try the 2 at the bottom of the page, and then I'll do them quickly so you can check. So for this first one, maximum is -1, minimum is -3, the midline is right in the middle at y equals -2. The amplitude from that middle to the top is just 1. And the period, if I trace it out, this is an up, down, and up, is 2 pi. On my last one, this one, the maximum, and it's kind of hard to tell, but we're going to say it's 3. Minimum is -3. Right in the middle is y equals 0. Amplitude is 3. And the period, if I trace out this whole thing, right, that's 1 cycle. If I kept going, we'd start that same pattern again. So that's 4 pi for the period. There's 2 more on the next page. I'm just going to switch over there. Okay. Why don't you try these 2? These 2 are more of like real life. Some of the stuff you'll have to estimate, but we do get into those type of problems. So on this one, it looks like the maximum is about 12. Get over to my pen. So 12. My minimum, I don't know, looks like it's about 1. If I go down here, right, it doesn't quite get down to 0. So the midline, this one might be a little tricky, so I'm going to use an average, is about 6.5 if I go right between that 12 and 1. If the midline is at 6.5, and it's kind of hard to get it perfect, if I'm not sure what this is, you probably could come up with this on your own, but we're going to do 12 minus 6.5 to find the amplitude, right? How much do I go up from the midline to the top? So that's 5.5. The period, here I can't even really see where the y-axis is, so maybe I start from here and trace it out. So that looks like it goes from about, I don't know, 2-ish out to 15-ish. So maybe I'm going to say the period is 13, 12. As I said, this is really estimating. So I'm going to write 13. And all of these values, when you have to actually write an equation, it'll be a little more exact. Moving over to the other one, maximum, maybe I say around 70. Minimum, I don't know. Let's say if I drew it a little straighter, we'll go with 10. And the midline, so 70 plus 10 is 80 divided by 2, and we can even see that, right? 40 looks like a good spot. So y equals 40. I should have written my y equals over here for the 6.5. The amplitude from 40 up to the top, right? 40 up to 70 is 30. And the period here, if I look at it, it looks like it's a little past 50. And if we were in class, we would talk about, well, why is that true? And this is a graph of the temperature over the year. We have weeks at the bottom here, so we kind of expect the temperature to be cyclical over a 52-week period. So if you had 50, that's fine. I'm going to write 52 here. Looking back at the other one, this is actually some sort of a graph about tides, okay, which repeat on about a 12-hour cycle if you measure the height of the water over that time. So any of these things that happen in nature that are cyclical can be modeled by trig graphs. The second topic on this page, and what we're going to start to connect this amplitude, period, and frequency to, are the transformations that we learned earlier in the year. So here, why don't you pause the video and just look over these transformations and read questions A, B, and C at the bottom of the page. So these 3 questions, and see if you can answer them, and then we're going to go over them. So we're looking at which group of transformations would affect the midline of a trig graph. And if I have a really rough sketch of a trig graph here, we're talking about which set of transformations would basically move it up or down to change the midline. And that would be our vertical shifts. So if I move the graph up or down, right, that's going to move the midline. Which group of transformations would affect the amplitude? So the amplitude is from that midline. How much does it go up or down? And that would be our vertical stretches or compressions, right? Stretching out the graph or pressing it back down towards the midline. So vertical stretch or compression. Lastly, which group of transformations in the table would affect the period of the trig graph? This is our most recent set of transformations. If I'm going to scrunch in this graph and actually make it go faster, I'm trying to draw this well. So I'm trying to draw this graph so you see that there's no change in the amplitude, okay? Now it just looks like a bunch of scribble, but you guys get the idea. Basically, I'm smushing it in, making it finish faster, we can think of. That's our horizontal stretches or compressions. It's like I'm smashing the graph back, or I could stretch it out forward in the horizontal direction. So horizontal stretch or compression. So on the next page, we're going to start to connect these transformation rules we know to how the equation of the trig graph would change when we make these changes to these 3 different qualities of the trig graphs. Okay, so I tried to fix all kind of the weird notation that didn't convert well into the video file. This obviously does not like Greek letters and fractions, like the pi's, it doesn't like in the fractions, and then the y equals were kind of messed up. So first off, we have a new definition. This is something just for trig graphs. When we do a horizontal shift, so in our transformation rules, that would be like f of x plus a, that's going to go to the left, or f of x minus a to the right. That's actually called a phase shift. So we're going to use those words interchangeably. And it says we will only identify phase shifts. They're kind of tricky, especially when you're first learning trig graphs, to do looking at the graph, so they're just going to be things we look for when we look at equations. So here are two examples of what equations can look like when we transform trig graphs. Going through, first off, on the previous page, we said the midline was impacted by a vertical shift. So that would be the number that we add at the end. So basically, whatever number is added or subtracted at the end, that is the midline. The amplitude of the graph, we said, was a vertical stretch, and we know vertical stretches are a times f of x, so that's the front number. We never say the amplitude is negative, so even if there's a negative out here, that would actually be a reflection in the x-axis, so whatever that number is, we just make it positive, and that's the amplitude. The maximum and minimum values, usually we just find from the graph, but basically once we identify the midline, right, that's what's in the middle, we would add the amplitude, go up the amplitude to the maximum value, and subtract the amplitude to go down to the minimum value. Missed one of my pies. This is probably the trickiest one. So basically, when we change the horizontal shift, and actually I'm going to pause the video and erase the mess so you can see this a little better. So here, basically we're talking about the period of the graph. The period you can think of as how long it takes to get somewhere. So that's going to be impacted by your horizontal stretch or compression, which would be the number that's multiplied by x, because those rules involve f of ax. So basically you can think of this number, and I'm going to write bx here because b is the number I have up there, just so it's not quite so confusing. That number that goes with the x here, basically the bigger b is, the faster the graph is going, so the less time or the shorter period there's going to be. So the normal period of 2 pi is here, and if I go faster, I'm going to divide and make that period value smaller. I'm going to get there faster. It's going to take me less time to go there. So lastly, the phase shift is the value of c. So that's whatever is added or subtracted to the x, and really only identifying in equations is all that you have to worry about. So I know this is a lot at once. Remember, we're doing 4 lessons on this. We're introducing it all today. I'm going to look at this example equation down here. So I know this is a cosine graph. From this information, we always kind of start out with midline. It's the easiest. So whereas normal cosine has a midline of y equals 0, this graph is going to have a midline of y equals 9, okay? The parent cosine curve has a midline of y equals 0, shift up 9, midline of 9. The amplitude or absolute value of a is 5, okay? So basically here, amplitude, we've stretched this out from an amplitude of 1 to an amplitude of 5. So the maximum, the midline is 9, just to kind of draw a quick graph. I mean, it does move, shift a little bit. So if I made my midline at 9, it's going to go up 5, up to 14, and this is a sine curve. As I said, we're not really worrying about that piece now. We're just saying how it goes up and down. So it goes up to 14, and on the other side it goes down 5. Okay, so it goes down to 4. So maximum is 14, right, midline plus the amplitude. Minimum is 4, midline minus the amplitude. Lastly, this graph is pretty fast because it's 3 being multiplied by that x. So instead of taking 2 pi to finish, it takes 2 pi divided by 3, 2 pi divided by b to finish. Lastly, if we drew this graph, we would take the normal cosine curve, okay, which looks something like this. As I said, it's been transformed in other ways, and we would shift it pi over 2 to the right based on this. Okay, so that's the phase shift. One other small comment that's important, if there are no parentheses after the trig function, so if you see cosine of 2x plus 3 like you see here, the parentheses is just around what's multiplied.